In the last lecture we see the properties of the transpose of the matrix. Okay, properties of transpose of the matrix and the examples in the exercise 4.7. Now we see the remaining examples in the exercise 4.7. We have in the last lecture the 9 examples are done. Now the continue the exercise 4.7, the 10th examples on the properties of the transpose of the matrix. Okay, here the 10th example. If A is equal to -1, 2, 1, -3, 2, -3 and B is equal to 2, 1, -3, 2, -1, 3. Prove that A plus B transpose of transpose is equal to A transpose plus B. Okay, here notation for the transpose we can write T or a dash. Okay, here given the two matrices A and B, we have to prove A plus B transpose of transpose is equal to A transpose plus B. Okay, here this example we can prove without the calculation of these two matrices, only by using the property of the transpose of the matrices. Here in the last lecture we see the properties A plus B whole transpose. Okay, we can transpose it is a T or dash, then it is A transpose plus B transpose. Okay, and the transpose of transpose is equal to the matrix itself. Okay, in the last lecture we see those properties. Here using these two properties we have the proof without using the calculation. Okay, here the LHS, it is A plus B transpose of transpose. Okay, here using this property separate transpose, that is A transpose plus B transpose of transpose. Here first matrix is A and second matrix is B transpose, and again it is A transpose plus B transpose of transpose, it is a B. Okay, and it is RHS. It is a proof. Okay, without using the calculation, without taking the addition or the transpose of the matrix. Okay, only by using the properties. Okay, now this example we prove by using this example. Okay, here the given matrices, given A is equal to, it is -1, 2, 1, -3, 2, -3 and B, here it is 2, 1, -3, 2, it is -1, 3. Then first find A plus B transpose of transpose. Now A is given but B transpose is not given, here it is only B. Therefore first we find out the B transpose of matrix B. Okay, here it is a 3 by 2, the transpose of B it is a 2 by 3, then it is a interchanging rows and columns, -1 and 3. Okay, here see carefully, it is a B transpose, 2, 1, -3, 2 and it is -1, 3, row becomes here column. Now first find the A plus B, A plus B transpose, and then it is A plus B transpose. A, it is -1, 2, 1, -3, 2, -3 plus 2, -3, -1, 1, 2, 3. Then adding them we get -1 plus 2, it is 1, 2 plus -3, that is 2 -3, it is -1, 1 plus -1, it is a 0, 3, it is -3 plus 1, it is -2, 2 plus 2, it is 4, and -3 plus 3, it is a 0. here it is equation number 1. Okay, A plus B. Okay, it is not equation number 1, it is only A plus B transpose. Now we want to find the A plus B transpose of transpose. Therefore A plus B transpose of transpose, and then it is 1 minus 2 minus 1 4, and it is a 0 0. It is a transpose of this matrix. This columns becomes row, or this row becomes columns. Okay, now it is equation number 1. It is RHS. Now find the LHS. Okay, here see carefully this also. Okay, now first find the A transpose, and A transpose is equal to A is this matrix, then its transpose is minus 1 minus 3 2 2 1 minus 3. It is the A transpose. Now we want to find the A transpose plus B, then A transpose minus 1 minus 3 2 2 1 minus 3 plus it is a B 2 1 minus 3 2 and minus 1 3. Okay, here, and then it is the addition of these two matrices. Minus 1 plus 2 it is 1, minus 3 plus 1 it is minus 2, then 2 plus minus 3 it is minus 1, 2 plus 2 it is 4, 1 minus 1 0, and minus 3 plus 3 it is a 0. It is equation number 2. Okay, and from 1 and 2, from 1 and 2, A plus B transpose of transpose is equal to A transpose plus B. It is the proof. Okay, see carefully this. Now we see the next example. Next, example number 11. Prove that A plus A transpose is a symmetric and A minus A transpose is skew symmetric. Matrix where one, 2, 4, 3, 2, 1, minus 2, minus 3, 2. And the second example is here the name is, it is A. It is also A, name of the matrices. 5, 2, minus 4, 3 minus 7, 2, then 4 minus 5 minus 3. Okay, here these are the two examples. In this we have to show A plus A transpose. A plus A transpose is a symmetric matrix and A minus A transpose is a skew symmetric matrix. Okay, now here there are the two examples. We solve this second example, the example number 1 for the homework. We can solve the second example. Okay, here in the second example, here it is given A is equal to 5, 2 minus 4, 3 minus 7, 2, 4 minus 5 minus 3. Okay, it is a matrix A. Now we find the A transpose. Okay, therefore A transpose is, here row becomes column. It is a 5, 2 minus 4, 3 minus 7, 2, and it is a 4 minus 5 minus 3. Okay, here it is A and it's A transpose. Now we find the A plus A transpose. Okay, therefore it is A plus A transpose is equal to, see carefully, A plus A transpose. A, it is a 5, 2 minus 4, 3 minus 7, 2, and it is a 4 minus 5 minus 3. It is a matrix A plus A transpose. It is a 5, 3, 4, 2 minus 7 minus 5 minus 4, 2, and it is minus 3. Okay, here A plus A transpose. Now the addition is here 5 plus 5, it is a 10, 2 plus 3, it is a 5, minus 4 plus 4, it is a 0, 3 plus 2, it is a 5, minus 7 plus minus 7, it is minus 14, 2 plus minus 5, that is minus 3, 4 plus minus 4, it is a 0, minus 5 plus 2, it is minus 3, and it is minus 3, it is a 0, sorry, minus 6, minus 3 plus minus 6, it is minus 6. Now it is A plus A transpose. See carefully now, in this matrix A plus A transpose, okay, a matrix is a symmetric matrix if its transpose and the matrix are the same. If its transpose and the matrix is the same, then the matrix is a symmetric. Okay, now here if A is equal to A dash, okay, A transpose are same, then the matrix A is a symmetric. Here we want to prove that A plus A transpose is a symmetric. So find the transpose of this matrix. If this matrix is the same, then it is a symmetric matrix, which is it is A plus A transpose. Also, okay, here we can prove if in the matrix Aij is equal to Aji, the elements in the matrix, okay, here Aji, row number and column number only interchange. Here Aij is equal to Aji. That means here 1 2 and 2 1 are the same. 1 2, it is the position of the element, that is first row second column, and 2 1, it is the position of the element second row first column. Here 2 3, 3 2 are the same. In this, see carefully, check this. Here 1 2 and 2 1, 1 3, 3 1, then it is 2 3 and 3 3 are the same. Therefore we observe this, it is a symmetric matrix. Okay, here it is Aij in the matrix, all elements in the form Aij is equal to Aji. Therefore A plus A transpose is a symmetric matrix. Okay, here all elements in A plus A transpose are, it is Aij is equal to AJI. Here, see carefully. And therefore, A plus A transpose is a symmetric matrix. Okay, here. केअरफुली पहा. आणि जर तुम्हाला हे लिहायचं नसलं तर मग काय करणार, या मॅट्रिक्सचा ट्रान्सपोज काढा आणि पुन्हा हाच मॅट्रिक्स आला तर काय असणार, ट्रान्सपोज मॅट्रिक्स. सॉरी, इट इज ट्रान्सपोज आणि मॅट्रिक्स दोन्ही सेम असले तर काय असणार, ते सिमेट्रिक मॅट्रिक्स. मग तुम्ही ए प्लस ए ट्रान्सपोज इट इज, आणि त्याच्यानंतर काय काढणार, ए प्लस ए ट्रान्सपोज ऑफ ट्रान्सपोज, आणि देन बोथ मॅट्रिक्स आर द सेम, then it is a symmetric matrix. Or we can write only this, Aij is equal to Aji. It is a symmetric matrix. Now the second proof, it is A minus A transpose, and we can find the matrix A minus A transpose. It is matrix A, it is 5 2 minus 4, 3 minus 7 2, 4 minus 5 minus 3, minus the transpose of this matrix. It is 5 3 4, 2 minus 7 2, 2 minus 7, it is minus 5, and minus 4 2 and minus 3. Okay, here it is a transpose. Here it is a plus A transpose, here A minus A transpose. Okay, therefore the subtraction of the corresponding elements, 5 minus 5, it is a 0, 2 minus 3, it is minus 1, minus 4 minus minus 4, it is minus 8, 3 minus 2, it is 1, minus 7 minus minus 7, it is a 0, 2 minus minus 5, it is 7, 2 minus minus 5, that is a 2 plus 5, 4 minus minus 4, it is 8, minus 5 minus minus 2, it is minus 7, and minus 3 minus minus 3, it is a 0. Okay, here all elements in matrix A minus A transpose are in the form of Aij is equal to minus Aji. Okay, here for the symmetric matrix Aij is equal to Aji, but skew symmetric matrix Aij is equal to minus Aji. Here 1 1, it is 1 2 position element, it is a 1, so 2 1 position, it is a negative of this, that is minus 1, it is plus 1, 1 3 position, it is minus 8, then 3 1 position, it is 8, here it is 8, 2 3 position, it is a 7, so the 3 2 position, it is a minus 7. Okay, here it satisfies the conditions of the symmetric matrix, sorry, skew symmetric matrix, and therefore A minus A transpose is skew symmetric. It is a skew symmetric matrix. See carefully. Okay, we can solve. We solve this the second example. Okay, the first example for the homework. Same procedure. First it is A. First find the A transpose. Then we get the A plus A transpose, and A plus A transpose, it is a symmetric, and A minus A transpose, it is a skew symmetric matrix. Okay, here. Now the next example. Example number 12. Express the following matrices as the sum of a symmetric and skew symmetric matrix. Again, there are two examples. The example number 1, here it is a 4 minus 2 3 minus 5, and the second example is 3 minus 1 minus 2 1 minus 4 minus 5 2. Okay, here express the following matrix. Okay, suppose this matrix we consider it is a A. Okay, we know the A plus A transpose is a symmetric matrix and A minus A transpose is a skew symmetric matrix. We can express the matrix, the given matrix, in the form of the sum of the symmetric and the skew symmetric matrix. Okay, here we know that it is a A plus A dash, it is a symmetric, and A minus A dash, okay, A minus A transpose, it is a skew symmetric, and the matrix A, see carefully, matrix A is 1 by 2 into A plus A transpose plus 1 by 2 A minus A transpose. Okay, here it is a symmetric, that means 1 by 2 into this, it is a symmetric matrix. It is a skew symmetric, therefore it is a skew symmetric matrix. Okay, and here it is a addition of symmetric and the skew symmetric matrix represent this matrix A. Okay, here it is A and it is A plus A transpose, it is a symmetric, and A minus A transpose, it is a skew symmetric. Okay, we know that it is a properties, and using this property we know this result. Okay, here for the solution we know that A plus A transpose, okay, we can take dash or T, A plus A transpose is symmetric and A minus A transpose is skew symmetric. Matrix. Okay, and therefore we know it is a matrix A is equal to 1 by 2 into A plus A transpose plus 1 by 2 into A minus A transpose. Okay, here it is a result. Now we check first this example and then the second example. Okay, here now for the first example, let the A matrix is 4 minus 2 3 minus 5. Okay, therefore we can write A transpose is equal to 4 minus 2 3 minus 5. Now we find A plus A transpose and A minus A transpose. Okay, therefore A plus A transpose is equal to the matrix A. It is a 4 minus 2, 3 minus 5 plus 4, 3 minus 2 minus 5, and the addition is, see carefully, the addition A plus A transpose. 4 plus 4 it is 8, minus 2 plus 3 it is 1, 3 plus minus 2 it is 1, and minus 5 plus minus 5 it is minus 10. It is the addition, that is, it is A plus A transpose. Now we find A minus A transpose. And A minus A transpose, A, it is 4 minus 2, 3 minus 5 minus 4, 3 minus 2 minus 5, and then the subtraction is, see carefully, A minus A transpose, 4 minus 4 it is a 0, minus 2 minus minus 3, sorry, minus 2 minus 3 only, it is a minus 5, 3 minus minus 2, here it is a plus, therefore 3 plus 2 it is a 5, and minus 5 minus minus 5 it is a 0. Here it is A plus A transpose and it is A minus A transpose. Now we can find the matrix A is the addition of the symmetric and the skew symmetric matrix. Here it is a symmetric matrix and it is a skew symmetric matrix. Therefore, okay, we can write here. Now we can write here 1 by 2 into A plus A transpose plus 1 by 2 into A minus A transpose, and this is equal to 1 by 2 into, here we can write here 1 by 2 into A plus A transpose, it is 8 1 1 minus 10, 8 1 1 minus 10, and plus 1 by 2 into 0 minus 5 5 0. Here A plus 1 by 2 into A plus A transpose plus 1 by 2 into A minus A transpose, 1 by 2 into A plus A transpose plus 1 by 2 into A minus A transpose. Then these two matrices becomes 1 by 2 into 8, it is a 4, it is 1 by 2. You can multiply the all elements in the matrix by 1 by 2, then again it is 1 by 2, and here it is minus 5 plus here we multiply by 1 by 2, okay, here it is a 0 minus 5 by 2, 5 by 2, and it is a 0. Now see carefully, it is a symmetric matrix and it is a skew symmetric matrix, okay, it is a symmetric matrix and it is skew symmetric matrix, and therefore the addition of both two matrices, 4 plus 0 it is a 4, see carefully, 1 by 2 plus minus 5 by 2, carefully calculation, 1 by 2 plus minus 5 by 2, that is minus 4 by 2, म्हणजेच काय minus 2, minus 4 by 2 it is 1 by 2, and minus 5 by 2 it is minus 4 by 2, and minus 4 by 2 is minus 2, 1 by 2 plus 5 by 2, 1 by 2 plus 5 by 2 it is a 6 by 2, and 6 by 2 it is a 3, minus 5 plus 0 it is a minus 5, okay, and here it is a matrix A, okay, therefore it is A, okay, that means A, this matrix, okay, express the following matrix, that means express this matrix as the sum of symmetric and the skew symmetric matrix. Therefore we can write the last answer here, matrix A is the sum of symmetric and the skew symmetric matrix. Therefore the matrix A is sum of, it is a symmetric matrix it is a 4 1 by 2 1 by 2 minus 5, and skew symmetric matrix. Zero, 5/2, 5/2, 0. It is minus 5/2, 0. Sorry, it is minus 5/2 and 5/2, 0. Here, the matrix A is the sum of symmetric and the skew symmetric matrix. Okay, here, matrix A is the sum of symmetric and this skew symmetric matrix. Okay, see carefully. Now we see the second example in this. Now the second example. Let the matrix A 3, 3, minus 1, minus 2, minus 2, 1, minus 4, minus 5, 2. Therefore, A transpose three, 3, minus 1, minus 2, 1, minus 4, minus 5, 2. Okay, here it is A and it is A transpose. Okay, it is a matrix. We can prove. Okay, here it is A matrix and it is A transpose. Okay, here we want to prove that the matrix A is the addition of symmetric matrix and the skew symmetric matrix. Therefore, we know that the symmetric matrix, it is A plus A transpose. Therefore, we can find the A plus A transpose. Then the matrix A 3, 3, it is minus 1, minus 2, 1, minus 4, minus 5, 2, plus it is A dash 3, minus 2, minus 4, 3, minus 2, minus 5, minus 1, 1, and it is a 2. And then the addition of these two matrices, 3 plus 3, it is a 6, 3 plus minus 2, that is 1, and minus 1, minus 4, it is minus 5. Then minus 2 plus 3, it is 1, minus 2, it is minus 4, 1 plus minus 5, it is minus 4, 1, and it is minus 5, minus 4, minus 1, minus 4, and it is minus 1, it is minus 5, minus 5 plus 1, it is minus 4, and last 2 plus 2, it is 4. Okay, here see carefully, it is A plus A transpose. Now we find A minus A transpose. A, it is a 3, 3, and minus 1, minus 2, 1, minus 4, minus 5, 2. It is a matrix A, minus 3, minus 2, minus 4, 3, minus 2, minus 5, minus 1, 1, and it is a 2. And then this is equal to, here, subtraction, 3 minus 3, it is a 0. 3 minus minus 2, that is a 5. Okay, 3 minus minus 2, that is 3 plus 2. Minus 1 minus minus 4, that is minus 1 plus 4, it is a 3. Minus 2 minus 3, it is minus 5. Minus 2 minus minus 2, that is minus 2 plus 2, 0. 1 minus minus 5, it is a 6. Minus 4 minus minus 1, that is minus 4 plus 1, it is minus 3. Minus 5 minus minus 1, it is minus 6. And 2 minus 2, it is a 0. It is A minus A transpose. Okay. It is A plus A transpose and it is A minus A transpose. Now we find the 1 by 2, A plus A transpose and plus 1 by 2, A minus A transpose. Therefore, here we can write it is 1 by 2 into A plus A transpose. It is 6, 1 minus 5, 1 minus 4 minus 4, minus 5 minus 4 and 4, plus 1 by 2 into A minus A transpose. It is a 0, 5, 3, minus 5, 0, 6. Okay. Then minus 3, minus 6 and 0. Okay. Now we can multiply this matrix by 1 by 2 and this also 1 by 2. Then we get the two matrices. We multiply this 6 by 1 by 2, it is a 3, 1 by 2 and it is minus 5 by 2. Okay. Then 1 by 2, minus 2, minus 2. Then minus 5 by 2, minus 2 and it is a 2. We can multiply by 1 by 2. Now again we multiply by 1 by 2 to this matrix, that means we multiply all elements by 1 by 2. Then plus, it is a 0, 5 by 2 and it is a 3 by 2. It is minus 5 by 2, 0 and it is a 3. Okay. Then minus 3 by 2, minus 3 and 0. Okay. Now see carefully, it is a symmetric matrix and it is a skew symmetric matrix. Here 1 by 2, 1 by 2, minus 5 by 2, minus 5 by 2, minus 2, minus 2. Here 5 by 2, but here it is a minus 5 by 2. 3 by 2, it is minus 3 by 2. 3 and it is minus 3. Symmetric matrix Aij is equal to Aji, and in the skew symmetric matrix Aij is equal to minus Aji. Okay, the position of the elements. Okay, now it is a symmetric and it is a skew symmetric. Now we adding the symmetric and the skew symmetric matrix, we get the matrix A. Okay, here 3 plus 0, it is a 3. 1 by 2 plus 5 by 2, that is 6 by 2, again it is a 3. Minus 5 by 2 plus 3 by 2, see carefully, minus 5 by 2 plus 3 by 2, that is minus 2 by 2, means minus 1. 1 by 2 plus minus 5 by 2, that is 1 by 2 minus 5 by 2, that is minus 4 by 2, it means minus 2. Minus 2 plus 0, it is minus 2. Minus 2 plus 3, it is 1. Minus 5 by 2 minus 3 by 2, it is minus 8 by 2, that means minus 4. Minus 2 minus 3, it is minus 5 and it is 2. See carefully this, and this is a matrix A. That means matrix A is the addition of symmetric and the skew symmetric matrix. Matrix A is the addition of these. It is a symmetric matrix and it is a skew symmetric matrix. Okay, addition of these two matrices. Okay, it is a symmetric, it is skew symmetric, but when we multiply by 1 by 2 to this matrix, it is also symmetric matrix. We multiply this matrix by 1 by 2, again it is a symmetric, skew symmetric matrix. That means these two matrices, it is a symmetric and it is a skew symmetric matrix, and here addition of the symmetric and the skew symmetric matrix represent this matrix A. Therefore it is A is equal to, it is a symmetric addition of the symmetric matrix plus skew symmetric matrix. Okay, here see carefully this. Now we see the next example. Here A is addition of symmetric and it is a skew symmetric matrix. Next example number 13. If A is equal to 2 minus 1, 3 minus 2, 4, 1, and matrix B is 0, 3, minus 4, 2 minus 1, 1. Then verify that. Verify that number 1, A into B transpose is equal to B transpose into A transpose, and number 2, B into A transpose is equal to A transpose into B transpose. Okay. Now here given that the matrices A and B, and we want to verify A into B transpose. First find the A into B and then its transpose is equal to B transpose into A transpose. Okay, verify that, and it is obviously show. Okay, because it is a property. Okay, A into B transpose is equal to B transpose into A transpose. Okay, here. Okay, now we see first example. First find the A into B. First find A into B is equal to the matrix A. It is a 2 minus 1, 3 minus 2, 4, 1 into matrix B, 0, 3 minus 4, 2 minus 1, 1. Now we take the multiplication of these two. Here, first row, first column, that is 2 into 0, it is a 0 minus 2. First row, first column. Now first row, second column, the multiplication, it is a 6 plus 1, 6, and it is minus 1 into minus 1. Now first row, third column, therefore it is a minus 8 minus 1. Okay, minus 8 and it is minus 1. Now second row, first column, it is a 0 minus 4. Second row, first column, it is 3 into 0 minus 2 into 2, it is minus 4. Second row, second column, it is a 9 plus 2, 3 into 3, and minus 2 into minus 1, it is a plus 1. Now second row, third column, 3 into minus 4, it is a minus 12, and minus 2 into 1, it is minus 2. Okay, then third row, first column, 0 plus 2. Third row, second column, 12 minus 1. Then third row, third column, minus 16 plus 1. And then the calculation, it is minus 2, 7, and it is minus 9. See carefully. Minus 2, 7, and minus 9. Then minus 4, 11, minus 14. Minus 4, 11, and it is minus 14. Okay. Now third row, 2, 11, and it is minus 15. 2, 11, and it is minus 15. It is A into B. Okay, but it is a LHS, it is A into B transpose. Okay, therefore A into B transpose is equal to the transpose, it is minus 2, 7, minus 9, minus 4, 11, minus 14. The second row becomes second column. Now third row, it is 2, 11, and minus 15. It is equation number 1. It is LHS, A into B transpose. Now we want to find B transpose into A transpose. Okay, and first find A transpose and B transpose. Therefore A transpose is equal to, see carefully, here it is A, therefore A transpose, it is 2 minus 1, 3 minus 2, and it is 4, 1. It is A transpose, and B transpose is equal to, it is B, therefore B transpose, it is a 0, 2, 3, minus 1, it is minus 4, 1. It is B transpose. You have to multiply B transpose into A transpose. Therefore, B transpose into A transpose. First we can write B. Okay, first we can write B transpose. It is a 0, 2, 3 minus 1 and minus 4, 1 into the A transpose. It is a 2, 3, 4 minus 1, minus 2, 1. Okay. Here it is A transpose. Now we multiply this. Here first row, first column, 0 into 2, 0, and 2 into minus 1, it is minus 2. Therefore it is a 0, minus 2. First row, second column, it is a 0, minus 4. Then first row, third column, it is 0 plus 2. Now second row, first column, here it is a 6 plus 1. 3 into 2, 6, and minus 1 into minus 1, it is plus 1. Now second row, second column, here it is a 9 plus 2. 9, it is minus 1 into minus 2 plus 2. Second row, third column, it is a 12 minus 1. Okay. Now third row, first column, it is a minus 8 minus 1. Third row, second column, minus 12 minus 2. Minus 12 and it is minus 2. Third row, third column, minus 16 plus 1. And then it is minus 2, minus 4, 2. 7, 11, 11, minus 9, minus 14, it is minus 15. It is equation number 2. Okay, here from equation 1, minus 2, minus 4, 2, 7, 11, 11, 9, minus 14 and 15. From 1 and 2. From 1 and 2, we can write A into B transpose is equal to B transpose into A transpose. Okay, here this shows both are the equal. Okay, now the second example is again same. Here we can find A into B. In this, first find B into A, then transpose, and then A transpose and B transpose, and the multiplication of A transpose into B transpose. In the first example, here we have it is a B transpose into A transpose. Okay, here it is a second example for the homework. Okay, now we see the last example in this exercise. Example number 14. If A is equal to cos alpha sin alpha minus sin alpha cos alpha, then show that A transpose into A is equal to R, where I is unit matrix of order 2. Now here given the matrix A, it is cos alpha sin alpha minus sin alpha cos alpha. Okay, therefore A transpose is equal to cos alpha minus sin alpha cos alpha. Here it is given matrix A, we find the A transpose. Now we have to show A transpose into A is equal to identity matrix. Therefore we find the multiplication of A transpose into A. Therefore A transpose into A. Okay. Here we can write the first A transpose. It is A transpose cos alpha minus sin alpha into cos alpha into the matrix A, it is A matrix, cos alpha sin alpha minus sin alpha cos alpha. Okay. Here we multiply these two matrices, then the multiplication is, see carefully this, okay, first row first column. Okay, in the first row first element it is a cos, in the first column first element it is a cos alpha. Therefore here it is, we can write cos square alpha plus sin square alpha, because it is minus sin alpha, it is plus sin square alpha. Then first row second column cos alpha into sin alpha minus sin alpha into cos alpha into sin alpha, and it is minus sin alpha into cos alpha. Now second row first column, it is it is sin alpha into cos alpha or cos alpha into sin alpha, you can write anywhere. It is a sin alpha into cos alpha minus these two elements, cos alpha into sin alpha. Okay, now second row second column sin square alpha plus cos square alpha, and here cos square alpha plus sin square alpha, it is a trigonometric identity. Sin square alpha plus cos square alpha, it is 1, and here it is cos alpha sin alpha and it is sin alpha cos alpha, both are the same, and there is a subtraction, so it will be 0. Again sin alpha cos alpha, it is sin alpha cos alpha, it will be 0, and then it is 1 0 0 1. Okay, cos square alpha plus sin square alpha 1, cos alpha sin alpha minus sin alpha cos alpha 0, sin alpha cos alpha minus cos alpha sin alpha 0. Okay, and sin square alpha plus cos square alpha, it is 1, and it is identity matrix, and it is the proof. See carefully this.